Welcome today to the SS7 ISUP technical training. We'll try to demonstrate what we have in the SS7 world, including the upper layers, which is the ISUP protocol. Topics we will cover today, just an overview of SS7, more specifically on ISUP, the ISUP configuration, and the status, including the ISUP status and circuit status. So if I start with the SS7 overview, you have the ISUP stack or protocol that is hanging somewhere in the overall SS7 system. And it's really, the ISUP is really to control voice circuits. Right? So it can allocate voice circuits, deallocate voice circuits. It could be, the circuits could be not only voice, it could be fax, it could be data. But passing all the voice circuits that controls passes over time slots and E1, T1 time slots. Now, ISUP doesn't work by itself. It needs to connect to other levels of the protocol. And the lower layer of ISUP is MTP3. MTP3 level controls the point codes of the SS7 network, which we talked about in our MTP3 presentations. And it controls also the route. So that means where we can send the packets from the ISUP layer. The lower layer here are demonstrated by the MTP2, where you can encapsulate data into a TDM T1 or E1 time slot, and it's sent over TDM links at 64 kilobit per second or high-speed links. You can also, instead of sending over TDM lines, send over SIG-trend lines, and here we demonstrate M2PA, which is encapsulated into IP and SCTP. These packets are then sent over IP links here. Right? So, and can also be M2 UA or M3 UA that is used at this level here. But it does interface with MTP3, and that's how the communication goes from your ISUP level to your networks here. MTP3 also can interface with other protocols like SCCP. Right? So when the packets are received, it knows if it's an ISUP protocol message or a SCCP protocol message. And it will route to the correct application. If you connect to a traditional TDM network, what you have here is different elements of the SS7 network. It could be a SSP or STP or a SCP. SCPs are databases for 1-800 numbers, toll-free numbers, local number portability, and all these things here. STP are just relaying messages through the network, and the SSPs are where we terminate the ISUP messages. Between SSPs, there could be A-links going to STPs or F-links going to other ISUP terminations, okay, or SSP or ISUP terminations here. What is certain is that between each of the SSPs, there must be E1 T1s, because this is where the circuits or the voice and time slots are being controlled between the two ISUP layers. If you look at this more in details, the SSP is where you have your ISUP layer, and it goes through these lower layer protocols here. At the STP level, you only have MTP3, nothing above there. And on the SCP level, then you go all the way up to the SCCP to process those queries to the databases. If you look today, then it's the networks are migrating to SIG-trend. So then instead of being A-links towards the central of the network, then you have a gateway that you can do conversion between the A-link and SIG-trend. So then the data here is still TDM converted to IP, goes over to this SIG-trend IP network here. And then the SCPs, where they could be using TDM links, but of course the new SCPs are using SIG-trend and can interconnect directly between the systems here. The voice circuits here between the SSPs are still E1, T1. Right? So at this level, you still have the ISUP level here with MTP3, MTP2, and E1 T1s going to the SIGTRAN gateway. But once you've crossed the SIGTRAN gateway, then you have other lower layer protocols like M2PA, or it could also be M3UA here, and then your other protocols run over your SIGTRAN. So the ISUP protocol itself is like ISDN primary rate. So if you've seen this before, you see it's very similar messages. There's more information in SS7 ISUP than in ISDN because it references a larger system, but otherwise it's the same type of information. And the main function of the ISUP is to control the circuits. And the circuits sometimes are, we use different terms for the circuits. One is a time slot, because the circuit is also referenced by one TDM time slot. It can be a CIC, circuit identification code. It can also be called a voice channel, a fax channel, or a data channel. Right? So when we talk about circuits, it includes all of them. The CIC itself, or the circuit, is a virtual information that links a physical time slot from a specific T1, E1, end to end. Okay? So we can relate one virtual data from one side, which links to a physical time slot and a T1, E1. And on the other side, it's the same virtual information, but it's, of course, a different T1, E1, but the same physical time slot. I'll show you that later. You will see some examples. Each element in a SS7 network is identified by a point code, so that's true also for the ISUP. This is how other endpoints know how to reach your ISUP termination. And if you look at the lower layer of the ISUP protocol, it's either MTP3 or M3UA that you interface with. So if you look at the CIC, circuit identification code, end to end, here I took the example of a T1. So the yellow box here is one T1 connected from end to end. Of course, these are two different devices. So you see here it is trunk number 1, and on the other side, it's trunk number 10. So these are references local to each of the elements at the endpoints. But the CIC value that you see here, and you will assign one time slot a CIC value. So on this side here, CIC2 means it's trunk number 1 time slot 2. And the CIC2 on this side means that it is trunk number 10, CIC2 and time slot 2. Okay? You have this reference here also with CIC23, time slot 23, CIC24, time slot 24. The first time slot here is used by an MTP2 link. So this is optional. If you're using SS7 TDM, then you will have at least one of the time slot used by an MTP2 link. If you are using SIGTRAN, then you won't need to take one time slot to carry the MTP2 link. It will be carried over IP. And you see here we have one MTP2 link, but the second circuit group has no MTP2 link. So the time slot 1 is now CIC25, for example. Here it's identified by trunk 2 time slot 1. Here it's identified by trunk 11 time slot 1. Normally, in a traditional SS7 network, you always have two MTP2 links connecting endpoints to make sure that if one of the T1s go down, the other MTP2 link will still continue to work. And just one more thing here is normally it would be time slot 1 that is used for the MTP2 link, but it doesn't have to. It could be other time slot, for example, time slot 24. You could have multiple time slots being used for MTP2 link in one T1. In a E1 configuration, then normally it is time slot 16 that is being used to carry the MTP2 link. But then again, you can still have more MTP2 links for carrying more bandwidth between endpoints. Here you see you have circuit group 1. That's just an example of a name, circuit group 1, and it has 30 circuits. But the values of the circuits are 1 to 15 and 17 to 31. Okay, so you're not using CIC 16 because it's the MTP2 link. It's not true, for example, if you don't have an MTP2 link, you can here have 31 circuits, and then you start at a certain CIC value, for example, 33, and you go all the way to 63 here to give you all your valued circuits. If I demonstrate a regular ISUP call flow, so you have your local ISUP stack here and your remote ISUP stack there. You have your originating point code and destination point codes here to identify how to send the data. And there is negotiation for the lower layer. And depending on which lower layer you're using, this part will be different. And we gave other presentations to show what are these low layer initialization procedures. Once you have your MTP3 up or your MTP3 way up, then you can start having your ISUP messages. The first message that will be sent for connecting a call will be the IAM, initial address message. In there, you have a lot of information that I'll show you in a minute, but the main ones are the call lead number, the calling number, and the circuit identification code. The CIC is sent on the first IM that is being chosen. So this you have to be careful because if the trunk is incoming and outgoing, if you choose the same CIC for the outgoing and the incoming, there could be call collisions. When there's a call collision, the system will retry another CIC value. However, it's a good idea to have a different hunting scheme on both sides so that the CIC values don't collide so often. So the CIC is chosen initially in the message, and in all other messages of the ISUP protocol, the CIC will follow. So it's possible to do a filter of the CIC to know if it's the same call we're talking about. Once the call is completed, the CIC can be reused for another call. And remember that that CIC references one specific time slot in SS7 network. Normally, when you get the initial address message, you get quite quickly a ACM address complete because you could have overlap sending for SS7, but normally you have all your digits when you make your call. When you have address complete here done, there's a little bit of information in the ACM, like backward call indicators and other things. But I think the main one is probably the does it include the ringback tone or not? Traditionally, in SS7 networks, it will always include ringback tones, but when you have a SIP, ISUP to SIP gateway at some point, maybe there you won't have the ringback tone. But here it tells you if you do have it. If you do have it, there will be a path open between the destination and the source so that you get the ringback tone to the caller. And then once the remote endpoint picks up the call, you get the answer message, ANM, and the call is established. So you see that the protocol is very simple. You get only 3 messages to get the call running. If you don't accept the call, then you can send a release here, and it will just drop the call. Okay? It's a very simple protocol. Then one of the two sides can release the call after the call is established, and there will be a cause code for termination. Could be all kinds of things here. It could be a normal call termination, or it could be the call is busy or unallocated number, which would come from the other side. But that terminates the call, and you just get a release complete for this call. So in the SS7 ISUP messages, you have, like I mentioned, the CIC value, okay, the circuit identification code, which also represents a time slot. So that's always being sent in all the SS7 messages to really define on which time slot we're working. Then you have other information elements. For example, the call lead party number. You have the calling party number. So in the original specification of SS7, this is optional. But we know today you must have your calling party number there because your calls will be removed from the network if you don't identify yourself. You also have a calling party category, which can identify what type of call this is. You have nature of connection indicator, which also can specify if it comes from a satellite connection, if you have echo cancellation enabled on these connections. You have a forward call indicator, which can tell you if the number has been ported or if there's a ringback tone in the, like we saw in the A&M, the ACM, sorry, message. You have user service information, which displays the bare capabilities. There's not much to discuss here because the bare capabilities are for T1s are always G711 MULA and for E1 G711 ALA. But sometimes it can be used for other functions. Then you have the cause indicator, which is there, or release cause, we call usually. These are taken from Q850, ITU Q850, and you have a list there of values I will show you in a minute. So apart from those basic ISUP messages, you have other useful messages. BLO, that's block, to block circuits. So when you block a circuit, it becomes unusable. So you just mention to the other side that you don't want to use those circuits anymore. And you have CGB, which is circuit group block. So instead of blocking just one circuit, you block a full T1 or full E1. Okay? And the A is just the acknowledgement from the other side to accept to block the circuits. Okay? Both sides can block the circuit, so you could be locally blocked or remotely blocked or locally and remotely blocked. Normally, when a T1 goes down, the system will automatically block all the circuits from that T1. Then you can unblock the circuits, so it's UBL messages, acknowledge, circuit group unblock, acknowledge. You have COT or CCR for continuity tests. I will show you some examples of this. You have RSC to resynchronize circuits. So it could happen that for some reason the ISUP stack become confused with each other. So you can send a reset and that will resynchronize all the circuit states. You may get a call progress information, CPG. So when you get this message, this means maybe you change from in-band to no in-band ringback tone. It could be switched to a voicemail or some of these information. So it gives you information on what is going on before the call is connected. Other messages you can see which could help you troubleshoot networks is UCIC. So you have unequipped CIC. So that means one of the ISUP sides says, I want to use a specific CIC, for example, CIC 100. And the other side says, well, I don't know what is this CIC value. So either the CICs are not configured on the other side or they're not aligned. So sometimes there's a shift in the CIC values, and it is important because otherwise it's not the correct time slot that will be used in the conversations. If you talk about the release cause mapping, ISUP release cause are from 1 to 128, and I already mentioned it's from ITU Q850. So here I give you some examples. Value 1 is unallocated number. Value 16 is normal call clearing. 17 is user busy. 21 is call rejected. So these are all errors that you can get in ISUP conversation. When we talk about mapping, we need to switch to other networks. If you switch to ISDN, primary network, for example, it's going to be the same Q850 error messages. But if you go to a SIP network, then the release cause values will be different. So it could be 200, 300, 400, 500, 600 values. And for example, 200 is okay, it's good. 404 is not found. 486 is busy. 603 is declined. When we do the mapping, there will be default mapping. So for example, normal is okay. 1 unallocated, it's 404 not found. 17 is 486. And 21 is 603. All right. In our systems, these could be modified if they don't match what your network needs. When we get into the SS7 networks, we have, of course, we can work on the called and calling numbers, but there's much more information we can get from those SS7 parameters. For example, The nature of address for calling numbers are present in there, and they can be extracted and used in our routing scripts to manipulate the information or get more data. Other stuff that can be taken from the SS7 messages are charge number, originating line information. If the number has been ported, this appears in the SS7 messages or in the generic number. FCI forward or BCI backward call indicator. So there's all kinds of information you can get in there, and you can modify also these parameters to adapt different SS7 networks. And here you get all kinds of details in the routing script tutorial, so you can see every parameters that can be extracted from the system. There's one thing I forgot to mention here is that in when you do the SIP to the SS7 ISUP to SIP conversion, you can also do SS7 ISUP to SIP I or SIP T, and then you can put all the ISUP information in the SIP message, so you can also extract these information from the other network if it supports SIP I or SIP T. So then we can go with the configuration of the ISUP stack. It's pretty simple here. You just enable to make it available on the system. It's always included in a configuration, in a license for our devices. So you just enable it. And it works in a redundant mode. So here you need to specify the two devices that will be carrying this ISUP stack. If it's a 1+1 system, then just put your two devices here. If it's a standalone system, then of course you can only use the primary ISUP stack. And the ISUP information will remain synchronized between the two systems. You need then to configure the SS7 ISUP user part. The most important thing is the version. Of course, we support a lot of different variants of ISUP. The main ones are NC95 for North America and ITU 97 here for almost all the rest of the world. But you see, there's other variants we support. The other one is the subservice field. It just needs to match which type of network you are connecting to. Then these are default, so these are inserted by default into the configuration if it's not already there. Then you need to configure your ISUP interface. So you need to get the ISUP user part and network. There's nothing in network specifically, so you just need to allocate that. And the other important information is your point codes. So you need to have point codes in the system. You already have configured them if you configured your MTP3 network. But here you need to make sure that it says your point code, from which point code the ISUP messages will be generated and DPC to where it's going to go. So here you can create circuit groups once you have your ISUP interface up. You create one circuit group per T1 or per E1. And you need to specify which T1 will be used for that ISUP circuit group. And you need to specify the first circuit group value. So for example, if you choose 241, the first time slot here will be called CIC 241. And the last CIC here will be CIC 265. Then, so this is 242, 243, 244, 245, all the way up to 265. The name here is only important for referencing them into your local configuration. Here I just put secret group 10, but it may be useful to say, well, this circuit group goes to this destination. So then in your status, you will see this information, and you can identify better why this circuit group is blocked or down or not available. If you go with E1s, then of course you don't have 24 time slots, but you have here 31 time slots, and you still need to do the same thing. Choose the trunk, choose the first circuit, and give it a name here. There is here skip time slot 16 CIC. So you see here we're choosing CIC, but if you have your MTP2 link here, it's going to use this timestamp 16. And in some configurations, even on other E1s, we may not want to allocate a CIC for 16. So it's a specific case here that you can use. SS7 network access point configuration. So this will specify each of the destinations and all the circuit groups that are going to that destination. One important information you need to specify here is your hunting or channel usage. Like I mentioned, when you make a new call, the CIC is included. So if both sides use the same values of CICs, then it becomes, there's a bigger chance to get a call collision. So normally there will be one side that will be using one value like lowest, and the other side will be using highest CIC so that there's no conflict. But you have other options here that you can use. Then you need to select the circuit group. So you need just to select which circuit group you want, press here, and you add them. So an ISUP NAP could have just one circuit group, but could have multiple circuit groups. And these are logical elements reaching the same destination. You saw, if I just go back to the previous page, you saw here you have a profile that you can put. You have a default profile that works for most cases, but you can also adjust some parameters if you want to adapt your SS7 to different networks. And for example, we have here send charge number, i.e. in IAM. So this will add another information element to the initial address message. Don't forward early ACM, so you have options here. So you see the default is here unchecked. These ones are checked. And for example, here you can overwrite the forward call indicator and the backward call indicator. So by default, the mask is 0, so we don't overwrite anything. But if you put values here, like for example, FFFF, then it will overwrite here. The bits here are, it's a mask and it's a bit field. And you need to look in the specifications to know which bits need to be used. So the values, there's two sets of 8 bits here. The first 8-bit represents values H to A, which is in the specification. And the other is M to I. And here we give an example. Okay, so these are things you can modify. Once your system is configured, that's all you needed to do. Everything is ready. So then you can see the global status of the system. Of course, you want to have your lower layers like M2PA or MTP3 or MTP2, depending on which lower layers you are using. They need to be up, and also the TDM lines, right? They need to be up to be used. But here we're going to be looking at the SS7 ISUP status. Okay, so when we go to that global information, you just can see if it is allocated. So just to know if it's been there. You can see if the ISUP interface is available. So here I showed only one ISUP interface configured, but most likely you will have multiple ISUP interfaces in the system. So here you would have multiple elements, and for each ISUP interface, there is communication end-to-end on ISUP, and it's going to be able to know if it can reach the remote ISUP network. And then you have the global circuit state. Here it's just all the time slots, all the CICs of all the ISUP interfaces. So it's just a global view of here. You can see how many are ready to be used, so idle, and how many are incoming, currently outgoing, blocked, in reset mode, or down. You can see the status globally. Now, if you want to go, and it's interesting to have it globally, but it's more interesting to have it per circuit group. So then you can go and click on, instead of interface here, you go on the circuit groups. When you go in the circuit groups, you can see if they are idle per circuit group. And if they're incoming or outgoing calls, you can see if they are blocked, locally blocked, remotely blocked, or both locally and remotely blocked. If it's in reset mode, then it means that it's not synchronized end to end. Okay, so it may be the unequipped CIC we saw before, but for sure there's no communication there. So this was circuit group information, but you can also go per circuit. So you can here, instead of using the circuit groups, you can use per circuit information. So here is the global circuit group information, but here you have per circuit. So each of these time slots, okay, so you see the time slot number and the CIC value here, and you can see if it's idle, if there's a call incoming on that CIC, if there's an outgoing call, if it's blocked, if it's reset, and you also see here the continuity test result, this last one that was conducted, and I will talk more about that in a few minutes. You can control the circuit groups or per circuit as well, but here I'm showing the circuit groups. So for example, if you're in circuit groups, you can say, I want to block all the circuits of that circuit group. And so you have three choices: block. When you do block, it will send a block message to the other side. The other side will say, yes, I'm okay to block all these circuits. You have, and that's of course when you want to deactivate that T1. You don't want them, the other side, to use that T1 with those time slots. The normal mode is default. When you have default, all the circuits would be unblocked unless you have your T1 that is associated with the CIC that is down. If that T1 is down, it will send a block message automatically to the other end. The third mode is unblocked. And normally it's only for testing because this will force the channels to be unblocked even if the T1 is down. You have a group reset, so you can reset the circuit group. So normally we don't do this function, but if ever you have a doubt or you want to see on the traces what happens when you send a reset, you can do this. It will resynchronize the circuits. And the last thing you can do is a continuity test on a circuit group. So this is important to do after you've set up the system initially, and you use this here to make sure that your CIC are synchronized with your time slot. And let me show you how that works for a continuity check. You have your system on this side, and this is the remote system. You have T1s connected. Here, 23 circuits end-to-end connected to this. One of the circuits is an MTP2 link that you can send information end-to-end. Okay. So here you have, for example, CIC1 that is configured on that T1. So when you select your circuit continuity check test, then it will send a CCR on the line. That CCR, as I explained with the ISUP messages, it also includes the CIC value. Right? So it says, I want to do a continuity check on circuit number 1. Here we know that circuit number 1 is time slot 1 end to end. Okay? When the other side receives the CCR, it puts the line in loopback here. The one that is generating the CCR will generate a tone, and it's a very specific tone sent on those lines. If there is a loopback that was created here, it's going to be able to detect the tone it sent. Once you detect the tone, then you know it is successful because it went all the way through, and you know the time slot is matched with the CIC value. And then you get a release on CIC1, and you just say that succeeded. Okay? So if it succeeded, then you are good, and you can use this time slot for any other call. And here I show you the example of if you made a mistake, right? So you made a mistake and you connected the wrong trunk end to end. So for example, here trunk number 2, which has this CIC value, is connected to trunk number 3, which has this CIC value. So the ISUP upper layer thinks it's matched here, right, end to end, but physically you have connected the T1s crossed. Right? And it's very easy to do those mistakes in a network because you have all all these dispatch box you need to do, and it's easy to make those mistakes. So that's why it's a very good idea to do those continuity test. So then we do the same thing. We send a CCR from the incoming or our side to the remote side. This is carried over M2P2 links. It could be SIGTRAN links as well. Once it's received on this side, it will, if it says CIC33, right? So it's in this group. CIC33 is this group. So it's going to do a loop back here. We're going to be sending a tone on the CIC33. But you see here, since the T1 is not connected correctly, it goes to the wrong trunk and the tone is not received. So it will wait a short period of time to see the tone. If it cannot detect the tone, then it will say that the continuity check failed. And it's going to send a fail to the other side. And normally, the circuit then becomes unusable by the system. So a lot of things we can do for this. You can see all the status of the SS7 ISUP. Once you've checked out the status and everything looks okay, and you see there's a problem, you can't find it. It's a good idea to do a signaling trace. To do this, you need to connect to the unit and type TB6 trace. Automatically, that will create a capture file that is usable in Wireshark, and you can get this trace here. There is also a way to do a live signaling capture, and this is described in our troubleshooting tools on our wiki sites. Okay, now I'm going to show you my lab setup to show the ISUP configuration. So in my lab setup, I have lower layer, which are MTP2 and M2PA. I have MTP3 configured, which has some point codes, some routes, and link sets. I have an E1 to carry the voice traffic. It could have been a T1, right? And at the ISUP level here, I have my circuit groups, which links the physical time slot to the voice and data traffic. So if you look at this here, we are focusing on this part here. So you have you have the circuit groups here, CIC 3 to 31, which also reference here. So both of them, talk to each other like this, but the messages actually go down this way and all the way back up. I'm using the point code 701 on MTP3 and also at the ISUP level. Okay, so it's the same point code we're using here, and it's 702 for this side here. You see, I'm can either use MTP2 going over E1 or M2PA going over IP network, so both are possible. So let me show you the lab setup. All right, so if I go back up to the main status, I can see here I have SS7 ISUP allocated on the system. And my lower layers, I have MTP3, M2PA, MTP2. My TDM lines here are configured. All right, so just go through here at the ISUP level. I have my point codes first. I needed to have my point codes configured. So I'm using 701 here, used by my ISUP interface, and 702 here. Then I need to go here in ISUP. I just created a stack here. On my system here, it's a 1+1. So I put primary and secondary. But if you have a standalone system, you could just put primary and none. Then there's three things you need to do here. ISUP network, you see there's nothing to configure here. So you just specify which network here. You could have multiple ISUP network, one for NC, one for ITU, one for national network. Okay, so you could have multiple ISUP networks, but here I showed only one. And here you need to configure your ISUP user part. The main thing is, of course, the protocol variant. You need to configure here and choose which one. Here I'm using ITU in this configuration. And you have options for the subservice field that it needs to match the rest of the network. Then you can configure your ISUP interfaces here. So you can create new ISUP interface or take the one I already configured here. You just need to specify the user part and network. You need to make sure it matches the correct network here and your point code and the destination point code used in the system, which is the ones we configured earlier on for MTP3 level. You may have seen this in other configuration of the system. There's always timers here. If you put your cursor there, you will see what does that do and where to take that information. T4 is from the ISUP specification, so you can go there to see how to configure these timers. Normally, the defaults are good, and that's why we hide them. So here you can create a new ISUP circuit group or multiple. Let's say you have 10 circuit groups, then you can go faster by doing multiple. Here I created only one, and I called it circuit group 1. It will start at CIC3. You see I've used 2 time slots here. One is used by my MTP2, and one I just skipped for an example. Line service is line number E1 number 5. Okay, so you just have to choose the correct line service. These are configured here in TDM line interface. Then you can select all your circuits here. So the first circuit will be called CIC3, CIC4, CIC5, CIC7, okay, CIC31. You have more timers here. Each one are explained what they do. Okay. So these are your ISUP interfaces. So that's all you need to do on the ISUP side, and then you need to make sure that your network access point is configured. So here I have some for SIP, and I have one here for ISUP. So you need to give it a name. That's usually your destination where that goes to. The profiles, like I said, you can choose a profile. Each of the profiles are configured here in the profile section. So you can modify the behavior of your net. Maybe I can just show an example of this. So if I'd say, let's say this one here. So there's some things for voice over IP, for SIP, for SDP, but the ones we want to see for SS7 is these one, TDM here. This is where you have the options to modify. There's other stuff here for SS7 or ISDN, but mostly used for ISDN here. Okay, and the reset cause mapping that I talked about is down here. So you go all the way down and you select edit reset cause mapping. That's if you want to change the behavior of, SS7 to SIP, or even could change from SS7 to ISDN here. Okay, so then here you have your NAP. So here you have to choose your channel usage. So that's to prevent call collision. And you need to put your circuit group. So here you just, when you do it the first time, you just need to select, for example, circuit group 1, ISUP circuit groups. Could be other types here that you have. And then you push it with the left arrow, and this gives you a circuit. Normally, a NAP, an SS7 NAP ISUP will have multiple circuit groups, not just one T1 worth of time slot. It's going to be multiple. So you have this. I didn't mention here the overlap parameters in the presentation because we don't use this normally with SS7, but you could do overlap sending and overlap receiving. This is supported. And you can do call rate limiting like all the other networks in the system. Maximum call rate incoming, outgoing, and maximum calls incoming, outgoing. Okay, so that can help you to plan your traffic. Okay, so this is the configuration. That's all you need to do for SS7. Then I want to show you the SS7 status. You go there, go to SS7 ISUP. So you see there, you have your ISUP configuration. Just show that it's active on both the active and the standby system, or if it's a standalone, you will have only one here. The ISUP interface, you see if it's available here, and you have your circuit groups. That's like global information. Most of the stuff will be here in ISUP interface. You have just the state, not super interesting, but you will go here to circuit groups, and you get a global overview of the circuit groups. You have a small graphical overview to see what is going on when you have a lot of traffic. It's interesting to see that. I'm staying here in circuit groups. So you can see the status of all the circuit groups, number of idle, number of your group states here, block. Default is the default mode, and then block is blocking the circuits. Reset, you just type yes, and continuity test, you just need to do this here. So I will show you that in a minute. But you can also go per circuit. So you click on circuit 3 here, and you can do the same thing, but only for that CIC value if you want to test specifically this CIC value. Okay. So let's do this. I want to capture a trace and show you what happens when you do some process on the SS7 network. Okay. So when I start my trace, I see that I have my, let me just put it slightly bigger. I have my MTP3 messages and my MTP2 messages. And here it says also which variant it is. Here with my profiles, I can change if it's an NC, but in this case, I'm using IT. So you see these are useful for debugging either at the MTP2 level or the MTP3 level. But once you make sure that it works, your SLTM, SLTA are working, you don't need to go there anymore. So you will focus on the ISUP level. So you can just type ISUP in the profile here. So I want to make it smaller so you can see what's going on. So for example, if we send a block on one CIC, you will see, yeah, you will always have your point codes and eyes up, and you see it's a BLO message, and it was answered immediately with a BLA. So let's bring it up. So you have the lower levels here, MTP2, MTP3, and you have your ISDN user part, eyes up, and your CIC. You see it here as well. And blocking, and there's no other parameters for this message. So it just says block CIC3. If you select the block here, you say blocking acknowledgement. So when you do this, both sides have agreed to block the resource. So then if we refresh here, we see that it's locally blocked. Okay, we can also get information more global. We click on the status here. Circuit groups here, you can see that you have one that is locally blocked over the 29. If you click on circuit graphical overview, you can see that CIC3 is blue here, so locally blocked. Okay. If I unblock it here, put it back to default. Like I mentioned, not unblock because otherwise the T1 goes down, it won't work. And then you have UBL, unblock, and unblock acknowledge. So very simple here. You can do the same thing with, let's do the continuity check first. So you can do a continuity check request. You see here, it sends a CCR, continuity check request. It says on which CIC it needs to do this. Under the cover, there's some tones that are generated, loopbacks and everything, and you get a release here with normal call clearing when it works. When it doesn't work, it will return an error here. Then the other side just does a release complete. CCR, release complete, and that's it. So you see it's pretty quick, less than 100 milliseconds to do this test. You can do also, just go here on the circuit groups, the same thing. Instead of going circuit by circuit, you can do block of the whole circuit group. You will see here that locally blocked now there's 29. So you have no more circuits available. And it was a CGB that was sent. Circuit group blocking, and circuit group needs to specify which which CICs are, how many CICs are being blocked, right? So you can specify it here and a group supervision message here. CGBA acknowledgement. So if it's accepted, it's going to say CBA, block all the circuits, and you'll see that now you can't use any of the circuits until you unblock them. You get your CGU and CGUA here. So circuit group unblocking and acknowledgement. Okay, if I refresh here, I'll see that now they're all idle. Okay. And I can do a continuity test on all the circuits here. And you see, for each CIC, there's a CCR check that is being done. They're being done not as a group, but as individual circuits. So each one of them are being tested individually to make sure they are working. And you get a global view of the number of CCR that were working. Okay. Then the other thing I want to show is if we make a call. So if we make a test call, I'm going to go with my other system here to force a call to the system. So you see here, I have my IAM, ACM, and ANM. I stop my call, and I will have a release. So if I go to my IAM here, you see initial address message on a CIC. So here it has chosen CIC2 because my hunting group is the lower level. Here you have all the other information elements. The most important one is the call lead party number. So you'll see here the value 1001 is being used for my call, and you have some other information here. Subscriber number, nature of address. This is used sometimes. The rest is not used so much. Then you have your calling party number, and you see here it's an optional parameter, calling party number, but it's today in the networks it's mandatory. So you have the calling party number here, but you also have the screening indicator, the numbering plan, and the nature of address. Okay, these are things that are being checked in the networks. And you see there's other parameters like this is speech. Then you have here the calling party category, ordinary subscriber, forward call indicators. Here you can see if it's a ported number here and end-to-end indication. So this means if you want to have in-band data. The ACM is smaller, so normally it's just presenting. I mean, if it has ringback tone. Okay. And here in this case, it looks like there's no ringback tone. So let me just check the call trace here. I can see this call that came in. So I received the IAM here. This generated a SIP message. And okay, so the reason I'm getting no early media is that the 3CX PBX I'm using is sending a 180 ringing without any ringback tone. So here I send, there is no ringback tone available for that call. And so that's why we see here no indication. And next I have the answer message. It's very simple, no optional parameter, just says I accepted the call. Once you finish, then you just need to say release. The release has only one information element, which is cause indicator. This is a normal call clearing. If it would be something else, then you would have it here. Release complete. Again, there's no optional parameter. So you see the messages are very small in the SS7 network. The last thing I want to show here is the documentation that is available for SS7 ISUP. You have, and I have it here, but I'm gonna show you in the pages here. I have the ISUP overview, which is this page here, which is how to, what is this, how to configure the system. Then here it's the actual configuration, and it depends on what are the lower layers to decide which segment you're gonna look at. If it's TDM, it's going to be this one. If it's M2PA, it's going to be this one. And the ISUP part is only this step 4 here. Continuity tests, some explanations on continuity tests. You see the CCRs and stuff like that we explained just now. You have the termination cause code and the mapping. It's explained here in these pages. Troubleshooting. So here I showed you a call trace here with this, but of course we can go and debug more on the system. And then you have other resources for T-Media support, so you can contact our team and we will be happy to help you. This concludes our ISUP technical training. Hope you enjoyed it and it enlightened you. So please contact us if you have more questions on this. Thank you very much.